Hello everyone. In this video, we are going to introduce concept of delegates. Delegate can be described as a type-safe function pointer. We can say it is a placeholder for one or more methods. Return type and parameter types of delegate and methods must match. We have our empty script. To declare a delegate, we write accessor followed by delegate keyword. Now we define return type of delegate, so we'll go for void name, and just to keep it simple, with no parameter at all. So here we have defined our delegate, which returns void and takes no parameters at all. Now we have defined delegate of this type, so now we can create a field of this type. Let's go with private, and type is test delegate. We give it a name, something like this. So now we can define our functions. And make sure that the declaration of these functions matches also the declaration of delegate. Now we can assign functions to a delegate. We can write test delegate function in parentheses, or also test delegate function dot invoke. If we press F5, we can see the result. We can also change reference to second function. We can see this is call of the function 1, and this is call of the function 2. It is important to have the functions of the same types. For example, if we had a parameter of function 1 of integer, it would throw an error. In C#, delegates can be multicast. It means they can trigger multiple functions at once. Let's see the result. Press Ctrl F5. Okay. We can see that by invoking delegate only once, we have called function 1 and also called function 2. There is also other way to assign function to delegate, and it is by typing new test delegate, and we pass as a parameter this function. So by doing this, we are explicitly setting delegate. This gives us another way to multicast delegate using a plus symbol. And it works just the same. But once again, we just can keep it simple. Another way we can create function and assign it is by using anonymous methods. So we use keyword delegate. We write parameters that match our delegate declaration, so not at all. And here we have body of our function. And this is how we use anonymous methods. Now, another way of creating anonymous methods is by using lambda expressions. Lambda expressions are great because they are tiny and compact. They can simplify your code substantially. Lambda expressions can take parameters and return some value. So we have declared a delegate which takes two numbers and returns integer. We've implemented this anonymous method, which is addition of those two numbers, and we print it out on screen. Let's see, press Ctrl F5. It works very well. Now for the built-in delegates, there are three especially useful ones, and it is action, func, and predicate. First one we will look at is action. We can define it by action. As you can see, this action type takes no parameters and returns void. Action is a generic built-in type. As you can see, we have many options, but we will make it take two integers, and we will call it math action. To this action, we will assign some method that will take two parameters. So action takes any number of parameters and returns void. Now, if you want to have a return value, you use a built-in type called func. Here we have defined func, which takes value of type string and also returns value of type string. We have implemented some anonymous method, which will give text to upper, and we print out the result on the screen. Okay. Remember, the last one is always the result. And this method prints out if the number is less than a 5. Another useful built-in type is predicate, which takes only one parameter and returns Boolean value. So we've defined two predicates. The first one checks if the number is even or not, and the other one checks if the text is in lowercase. Let's see how it works. It works just fine. We've already mentioned that the return type and parameter types of a referenced method must match to the relevant delegate definition, but it is not completely true. C# allows some flexibility to a programmer when it comes to compatibility of delegate with a referenced method. Covariance permits method to have return type that is more derived than that defined in the delegate. In this example, we have method dogHandler, which returns object of type dog. This object is more derived than the object returned by the delegate. Covariance enables us to assign this method to this handler. Contravariance permits a method that has parameter types that are less derived than those in the delegate type. In this example, we have assigned to our handler a method with less derived type. In this episode, we've talked about delegate as a reference type to the method. We talked about some built-in types like action, func, and predicate. We have mentioned covariance and contravariance. I hope you found this video useful, and we see each other in the next video. If you like this video, don't forget to press the like button and give a subscribe. Stay tuned for next episodes.